Hello, this is Dwight Mitchell from Mitchell & Son 3D Printing Services. The purpose for this little live broadcast is because we often, over the last couple of months, we've been asked, we often get a email in, or we get a message coming to us saying, can you print this? And they give us a 2D flat image, so a JPEG or a PNG. So they just give us a hand-drawn image, and they say, "There we go. Can you 3D print that?" We can't print from a flat image as a traditional printer will print. 3D printing needs a 3D model, so we have to use CAD, which is computer-aided drawings, to be able to create a real-life object from a drawing or a image. So we can, but we need a lot of dimensions, because we've got to then recreate that. Oftentimes we get customers then who will then send us in a sample so that we can then measure that or scan it and then create the object. But a lot of times people don't have the sample that they want us to draw from, or it's just not feasible to send us that item. So we get often asked. So we charge a fee. We charge £80 to draw per drawing, to be able to draw that. And I'll show you how that works now. So we have we use Fusion 360, as you can see in here, and I'll go through a drawing that I've done to just show you how the processes of taking a 2D drawing. So we have a customer who sent us a PDF file with a hand-drawn image on, which we then took that and created a 3D model and then reproduced the item for him. So as we go into Fusion here, we get given the drawing, and we then can import it into Fusion 360 using this tool here and saying import, gives us the drawing. So from that, then we can then create a 2D model. Okay, so how we do that then is we use the drawing tool to be able to create that model. So here we have now created a model of the item. So I'll just turn that off. So here we have the drawing of the outside. As you can see, we've drawn that, taken that and drawn that as it is. Created another drawing of that using the drawing tools, and then we've extruded it. What extrusion does, extrusion's taken it from a flat object, because that's all we've done. We just recreated a flat object, and then it turns it into gives it the 3 dimensions, as said. So now we have your 3D model in front of us. It's not a complete model, because the holes for the screws, for the mounting screws, need to go over here, and the chamfers need to go in. So we've added the chamfers to that. As you can see there, we have now the chamfers in there, which we use the chamfering tool to do that at 45-degree angle to give us that nice rounded thing edge, which is as per the drawing, which I've just kind of put in there. So you can see the chamfered edge there in the drawing that we there want. So we've been able to do that using the chamfering tool. So now what we need to do is we need to create the drawings, the extra bits here for the mounting screws, which we've done over there. There's your holes there with a hole in. Extrude those. But now we've got 3 bodies, and we only want to end up with 1 body. But before we combine these bodies and put them in their place as they should be, we need to just put a little chamfer on them. So on both of those, we've now added our little chamfer using the chamfer tool. Again, so we can hide that drawing. We don't need that drawing anymore. So now but now we want to put them in they are in their right place now, but we also want to be able to combine it. So it's 1 object. It's not 3 objects. So that is what we have done now. So now all those 3 bodies, as you can see, there's only 1 body now, the main body. So we've now created that. We just need to then now make those holes. See the holes there aren't, they're blocked. So we need to open those up. So we again use the same drawing to just extrude those holes through, and then to move them as they should be. So there we go. Extrude them. Now they've extruded, but now we've got these extra bodies here. Hide the drawing. So we've got these bodies here. We're going to use the cut tool to make those holes. As we see there. And now we've cut them. Now we've got the holes. But now that we want to, so then they need to be chamfered, so that when the screws are on. So we've done that. There we go. And then that's it. So now we stand that up, put that into our real world environment, just so that we can send that to the customer and say to them, have a look at that. Are you happy with that? And then you can have a look. And then we have our real world item produced. The material that is simulated here is ABS plastic. Okay. So that is creating a 3D model. So what I want to do now is I want to just show you, let me just pull up my website, because in the website, once you've created the 3D model, which is great, now that can be actually used in in a variety of ways, using CNC machining or 3D printing, because that's pretty much what CNC machining will use. They'll use a CAD model, a 3D CAD model to create, even on the CNC mills or CNC turning. So any computer synchronized machining will use a 3D model. So as we go into here now, I'm just going to share my screen with you again. Okay. Just go into our website, which is so as we can see here now, our website. This is as it is when you go onto mitchellson.co.uk onto the website, and then you can we've downloaded that file, that 3D model into CAD. As an STL file. If you have an STL or an object file, OBJ just stands for object file, we can then upload that onto our website. What this does, then it gives you an accurate costing of what that is going to cost you. So what you see on our website is what you pay. It's there's no tricks or so you're not going to pay more than what is on here, except obviously the shipping, which is about £2.50 if you're in the UK, anywhere nationally within the UK. So this is now loaded up onto the viewer to be able to view as it is in, as you can see, it's a 3D model still. So we want to be able to produce that or get a costing for that in ABS plastic, or PETG, which is the same, but let's do ABS plastic. So it's going to cost you to print one of those £28. And why that's £28? It is the cost of 3D printing is based on the volumetric size plus the material used and the time. So what we got now is you can also add. Well, let me just go to this. The infill. A lot of people have said to me, we don't understand infill, because they've come to my website and they say, I don't understand what that infill means. The infill is just the strength that you're going to give, because the way 3D printing works is it'll print a 2mm layer, base layer, or 2 or 3mm base layer. Then it'll print like a honeycomb infill, and then on the top surface, again, print a 2 or 3mm thick layer to give you that solid look. But depending on the infill that you use, your inside of that is going to be honeycomb. So you break it open, you've got a honeycomb in there. The infill 20%, 40%, 60%, 80%, 100% is going to increase the cost, as I will show you. If I put this on, let's put on 80%, it increases from £28 the extra £10 for increasing. What that does, it just makes that part stronger because you've got more material. But the more material you use, the higher the cost, because it's going to stay longer on the machine. You're going to use more material, obvious. So that's how that all works. So I wanted to share that with you because we've been asked those questions. We can then also do a number of post-processing. I forgot to show you that. So we go back to this. So we got a post-processing, and so most items that come off a 3D printer generally are quite smooth and just need to be tidied up, because you'll have little stringy bits of material here and there, and you might have so it needs tidying up. So that's just standard. But if you wanted it to be smoothened, completely flat, so you don't see the 3D printing trace marks, then we charge you extra for that. We also charge extra for sanding and primer. So if you want us to sand it down and prime it so that it's ready for a top coat, we'll do that. Spray chrome is again a service that we offer. And what spray chrome is it gives it give your product a chrome-like finish at a fraction of the cost, or at least 2/3. So this is the chrome, spray chromed helmet, a sprayed chrome engine block, and wheel rims. Again, with chrome, you kind of get a basic metal, shiny metal finish, but with spray chrome, you can add the colors and have different colors for various different reasons for how you like it. But it gives that same chrome-like finish. Now, what is the difference between spray chrome and electroplating? Electroplating, if the item that you want electroplated has these little pits or has dents and wear in it, the electroplating will reflect that. So it fills it up as you electroplate, depending on how much you electroplate, and that also increases the cost dramatically. Is the electroplating uniformly across all surfaces will create a 2mm layer thick of chrome. So if there's pits in your material or in the item that you're having electroplated, you'll have those little valleys and those little dents. Spray chroming won't. Spray chrome will create an even layer finish across the surface of that item. You can spray chrome up to, I think it's 10mm thick, and it won't peel off. If you do that with electroplating, the more electroplating that you lay on a surface, the more risk of it actually peeling off. That's where the problem comes to that. Electroplating is also restricted to the size of the electro bath. And there's a lot of more electricity, a lot more chemicals that are used in the electroplating process, making it not as environmentally friendly as with spray chrome. Spray chrome, the size restriction is based on the size of your spray rim, because it's sprayed on rather than using a bath. The size doesn't really matter. You're not really restricted too much by the size of the item that you want. It is, again, I've been told, and I'm quite confident that the spray chrome process is as durable as in electroplating to some extent. And it does last for a relatively long time. It's probably half the price of electroplating, but you get the same finish, you get the same look. I know a lot of people want to stay with electroplating, far more expensive, far harder, far more unfriendly to the environment and to the planet, because I know that's what is on a lot of people's minds. electroplating, electrospraying, or spray chrome. Sorry, I get my words straight. Spray chroming is a far more friendly, kinder to the environment process that can be applied. Anyway, I wanted to share that with you. So I hope you have a good day. And if you listen to this, I do thank you for that. So this is Dwight Mitchell from Mitchell & Son 3D Printing Services saying, have a good evening and have a good day. Goodbye.